Okay, today we're going to talk about a third method for locating slope. This way is going to be from slope from two coordinate points or ordered pairs. So when calculating slope from two ordered pairs, and remember, another word for ordered pairs is just a coordinate pair. The slope formula is going to be used. And what is the slope formula? Well, it's m, because remember we use m as the variable to represent slope. M equal to y subset 2. And the way I'm going to type that in is control comma 2. I'm coming over here. I'll be okay. Minus y subset 1. So both of our y coordinates are going to be on the top, which leaves our x coordinates to be on the bottom. So x2 minus x1. So one of the things that we should notice is that it has a comma there. So what we should notice is that these 2 points right here, x2 and y2, they're going to come from the same ordered pair. And y1 and x1, they will come from the same ordered pair. So we have our y's on top, our x's on the bottom, and then vertically, these need to come from the same ordered pair. Okay? So another way, if you want to put some circles in here to remind yourself of that, you could put a control D there to copy it so they match up here as well. So we can see this is from one pair, this is from a second pair. So notice, again, what we just said. The y coordinate is stacked above its matching x coordinate. It does not matter which ordered pair is used for point 2 or which ordered pair is used for point 1. And that's what those 2's and 1's mean in the formula. So if we think back to our formula, we say this basically of y of 0.2 minus y of 0.1 over x of 0.2 minus x of 0.1, or y2 x1, right? It's not it's not a power, because this isn't a mathematical computation. This is a mathematical identifier or characteristic. Okay, so it doesn't matter which point we choose, this 0.2 and 0.1, we just have to be consistent in stacking the matching ones. So let's do an example. We have coordinate pair 2, 5 and coordinate pair -1, 11. I'm just going to take this first pair and I'm going to make it my first boxes. So imagine if I take this pair and I rotate it counterclockwise. Now I have 5 up above and 2 down below. So 5 is the y coordinate and 2 is the x coordinate, and they're from the same ordered pair and they're stacked. Second ordered pair or first ordered pair, doesn't really matter what we call them. What's most important is that the y and the x from the same coordinate pair is stacked on top of each other. So now we have 5 minus 11 and 2 minus negative 1. So 5 minus 11, and I think actually, we'll go back. We're actually going to rewrite the formula here so that we remember it. Just a little practice to put it into our brains. So y control, comma, 2. So y2, y of the second point, minus y of the first point. Remember, I'm using control, comma, to do and undo my subset there, or my subscript. And x2 minus x1. And we've already stated we're going to do 5 as our y2 and 2 as our x2, 11 as our y1, and negative 1 as our x1. So 5 minus 11. Remember, when it's subtraction like that, it's really like adding a negative. So it's really 5 added to negative 11. So opposite signs, subtract. 11 minus 5 is 6. And 11 is the bigger absolute number, so I keep its sign, which is a negative. So I end up with negative 6. Here, subtracting a negative, remember that changes to positive, because think of your number line. If your negatives are getting bigger, you're moving to the left. So the opposite must be true. When your negatives are getting smaller, that you're moving to the right, which is increasing. So 2 minus a negative, so this is going to become a plus. So 2 plus 1 is 3. So now my slope is listed as 6 over 3. And I need to look and make sure if I can simplify it because I am an 8th grade student. So I need to do that. So I know 6 divided by 3 is 2, and a negative divided by a positive is a negative. So negative 2 over 1, or just plain old negative 2, is what my final slope is going to be. So we have to remember two things, that it's always a ratio. So even when we write it like this, it's still a ratio. It's still negative 2 over 1. I'm just not writing it that way because I should know at this point that any whole number could be made into a fraction by putting it over 1. Why? Because anything divided by 1 is itself. So negative 2 divided by 1 is negative 2. Negative 3007 divided by 2 is negative 3007. 10 divided by, not divided by 2, by 1. 10 divided by 1 is 10. 3007 divided by 1 is 3007, etc. C2 there, so like, 2 is in my brain. So that is the slope formula. We're going to move on, and just to show you that, remember, same ordered pairs, different order. So let's just practice what our slope formula is again. Y2 minus Y1 over X2 minus X1. So in the last example, we used this point as our second point. Now we're going to switch it up and we're going to use this point. So we're going to have 11 over negative 1. So the x and y that are matching are still stacked. And 5 over 2. So 11 minus 5 is now going to give me a positive 6. And negative 1 minus 2. So that's still like playing plus negative 2 is going to give me a negative 3. And 6 divided by 3 is still going to be 2. And a positive divided by a negative is still going to be a negative. So I just wanted to show you this example so that we understand it doesn't matter when we're given two pairs, two ordered pairs. Doesn't matter which one we decide to be 0.1 and which one we decide to be 0.2, or which one, we could switch it around. What matters most is that the x and y from the ordered pair is stacked on top of each other in the formula when we're doing the slope formula. So the slope formula is the most versatile because it can be used with graphs, tables, mappings, or with provided ordered pairs. And the reason is because, when you look at a table, what comprises a table? Ordered pairs. When you look at a graph, what comprises a graph? Ordered pairs. When you look at a mapping, what makes that up? Ordered pairs. So it's the most versatile in that respect. Obviously, other methods that we learned include building slope triangles on a graph. So although we can use the slope formula when we're on a graph, building that triangle probably is easier. So why wouldn't we go with the easier method? And calculating, remember this is where we put in that delta. So we're going to do insert special character delta, looks like a triangle. And remember that delta means change in. Calculating change in y over, I'm just going to copy this to make my life easy. Copy, paste, change in x for a table. So 3 different methods to be used to accomplish the same goal, and that is to figure out the slope of a linear relationship. So your next slide is your GP, and I'm going to zoom out on this one. So there's only 3 problems on your GP. You're given 3 different sets of coordinate points, and you need to show, how you solved it and what your final answer is. Now, if your final answer is a fraction, I know there's not a fraction bar in this last box. You could either just leave it here, or if you need to simplify it, you can just put it in here as a fraction and just use the forward key as your kind of fraction bar. So that concludes the lesson on how to find slope given 2 points, 2 ordered pairs for a linear equation.